Okay, learning target number 5 is solving compound inequalities, and this video is probably going to be a lot longer than the other videos simply because there are two different types of compound inequalities we're going to discuss, and there's lots of very important information about each one of those that you have to keep in mind while solving, while graphing, while looking at things, a definition of vocabulary term. We're going to talk about interval notation. So there's lots of things that we're going to look at in this video, so please be prepared for quite a bit of information here in the next several minutes. First thing we're going to start with is we're going to talk about what is a compound inequality. And a compound inequality consists of two distinct inequalities, and they are joined by the word and or the word or. So this is where we get our two different types. One will be an and compound inequality. The other one will be an or compound inequality. Now I want to kind of break these two down and give you a little bit of information here at the beginning. And some of this we will review and discuss further on into the video. So first I want to talk about and. The compound inequalities dealing with the word and. There are some important things to make note of about this compound inequality. First of all, the final graph contains the overlap of the graphs of each inequality. And what this means is you've got, it's joined, there's two distinct inequalities. There's two of them. So you're actually going to have two different graphs, but you've got to combine them together for your final graph or your final solution. So when you're talking about an and compound inequality, we're looking at the overlap of those two graphs. Basically what you're looking for is the intersection. So we're only going to take the intersection of the graphs of our two inequalities. That's the only thing we're looking at, just where they overlap or where they intersect. Now as far as the solutions are concerned, the solutions must work in both inequalities. Again, you've been given two distinct inequalities joined by the word and. That means it works in this inequality and that inequality. So that means it has to work in both inequalities. So when you check your work and plug in values, that value must work in both inequalities. And then third here, the inequalities themselves can be written as one inequality. And we're going to discuss that further in some other examples about how you can actually take the two distinct inequalities and write them as one inequality. All right, the other compound inequality is or. When you have two distinct inequalities joined by the word or, when we talk about the final graph for that one, it contains each graph. So what that means is that you've got two of them, and you're just going to take both of them and put them on the same line. They may or may not overlap. With or inequalities, they could be running in opposite directions and never touch each other. They could overlap, but basically you just take both of them, take each of the graphs and put them on the same line. So that's what you do for a compound inequality joined by the word or. Now as far as the solutions, they must work in at least one of your inequalities. Show the rest of this. It can work in both, that's okay. If you pick a number and it happens to work in both of them, that's fine. However, it may only work in one, at least one. So it could work in this inequality or that inequality. So those are some rules about your solutions. And finally, the inequalities themselves cannot be written together. They must be left as two separate, distinct inequalities. You are not going to be able to write or statements together as one inequality. So just some general information to know about your compound inequalities. So make sure you have those listed because those are going to be really good to reference some of your problems, your examples that we're going to talk through. So let's start with problem 1, writing a compound inequality. Let's just focus on 1A first. Now this is just being able to go from a phrase to the actual compound inequality, but then also graphing the solution. So this is similar to just writing inequalities and writing equations that we've done in the past, except these are compounds, so they're going to be joined by the word and or by the word or. All right, so let's just take each one of these, and first of all, let's figure out what if this one's an and or an or statement. All real numbers that are greater than -2 and less than 6. So right here tells me this is an and compound inequality. So if you go back to your reference notes there, gives you some information, things that you can keep in the back of your mind while writing these. So one side of this is going to be one inequality, then we'll have the word and then we'll have another inequality. Now, all real numbers that are greater than, okay, well, here's when we talked about writing inequalities several videos ago, we talked about identifying what our inequality symbol will be. So this is greater than, so this is telling me that every real number that I can think of is greater than -2. Well, that doesn't tell me what variable to use here, so I'm just going to use x. So x represents all my real numbers. It has to be greater than -2. And, so I'm going to write my word and in here, less than 6. Well, there's not a whole lot of information over here, but what this eliminates writing a whole lot, rather you could write this as and all real numbers that are less than 6. So again, this tells us what our inequality symbol is going to be. Well, we have to go back and remember that we're talking about all real numbers, and we used x to represent all those real numbers. So we're going to use x to represent all those real numbers here, but they have to be less than 6. So there's our compound inequality, joined by the word and. But what we talked about when we looked at some of those important information about and statements, one of the things we talked about is that I could actually write this together as one statement. Because it is an and statement, I can combine those. Well, let's think about the reason why I can combine them and what that's going to look like. Think about all the numbers that are greater than -2. Okay, and I'm going to do like a little thought bubble over here. X is greater than -2. Just a few examples of those would be 0 and 1 and 2, and you could think of some more. X less than 6, of course this isn't inclusive, that doesn't include everything. X less than 6, some of the examples I could think of over here, less than 6, that could be 5, 4, even down into my negative numbers. Those are all less than 6. Well, think about all of your numbers. Do we have an overlap of numbers that are greater than -2 and the numbers that are less than 6? And remember, we talked about the overlap is what we're looking for, and in fact we do. We do actually have an overlap. So let's look at what these two graphs will look like independently, then we'll look at them together as our final solution, and then we can actually write our inequality together. So let's look at this one. X greater than -2. So here's my -2. That's my starting point. That would be -1, that would be 0, this would be -3, and this would be -4. X greater than -2. So an open dot at -2, because I'm not including -2, and I want everything larger than -2. So that's going to run in this direction. We've got some examples written over there in our thought bubble. Now let's look at this one. 6 is our starting point. This would be 7 and 8 out here. This would be 5 and 4 here. X less than 6, I'm not including the 6, so again that's going to be an open dot, open circle. And I want everything less than 6, so that's going to run in this direction. We have those examples over there in our thought bubble as well. Well, look at our two graphs. This one starts at 6 and runs to the left, and this one starts at -2 and runs to the right. And are these two eventually going to run into each other? And they are. So when we talk about the overlap of these two graphs, we want to talk about where do they intersect, where do they meet. Now keep in mind that this -2 is going to keep going and going and going and past the 6. And this one's going to keep going and going in the left towards the negative infinity and past the -2. But we don't care about all this extra stuff out here. We just want to know their overlap. It has to be in this one and in this one. So if I combine these two number lines, I have actually two starting points with a compound inequality. I'm going to start at -2 here, and I'm going to start at 6 here. Both of them are open dots. And if I talk about the overlap, that's the intersection. It's everything in the middle. And we could list some numbers in there if we wanted to. We've got -1 and 0, 1, 2, 3, 4, 5, and 6. And think about all these numbers. Are they greater than -2 and less than 6? And they are. So this is actually right here. This is the graph of that compound inequality. And you could pick numbers on the outsides of this intersection. If I try -4, -4 is not greater than -2. That automatically knocks that out. I could try 8. 8 is greater than -2. That works. But 8 is not less than 6, so it marks it out of that one. It has to work in both. It's one of the rules we talked about. Now, looking at our graph here, I'm going to actually write these two inequalities as one statement. And it's fairly simple. You can kind of design it based on your number line here. Our starting point, our lowest point is -2, and our highest point is 6. And the variable I used to represent both of those was x. So x represents all of these numbers inside here, and I've got my two endpoints here, -2 and 6. But I got to figure out what my inequalities are going to be, and this is actually very simple. I could go back to my original problem, or I could use this graph. But x is greater than -2, which means -2 is less than x. All right, so -2 has to be less than x, and x has to be less than 6. So this is an example of how you can write your compound inequalities that are and statements together as one inequality. This is the compound inequality, and this is the graph. Now this is dealing with our and statement. So let's look at problem 1b. This is going to deal with our or statement. All real numbers that are less than 0 or greater than or equal to 5. So there are two ors here, so we have to be careful. This or actually connects greater than or equal to, which tells us our inequality symbol. Now on the left-hand side, all real numbers that are less than 0. Okay, well, I can set this up, all real numbers similar to A. I'm going to use x for this one, and it has to be less than 0. Or, again, they don't have all this written. We're still talking about all real numbers, but this time they have to be greater than or equal to 5. So greater than or equal to 5. So x less than 0 or x greater than or equal to 5. And that's it. I cannot combine those. We talked about how or statements cannot be written as one inequality, so that's it. This is your answer as far as the inequalities. But we do have to graph these. So let's look at the graph of x less than 0 first. Here's my starting point, which is 0. This would be 1 and 2, -1, -2. X less than 0, we're not including 0, so an open dot. And we want everything less than 0, so that would be all my negative numbers back here. Let's look at the graph of this one. X greater than or equal to 5. Well, my starting point is 5. Here's 6 and 7. Here's 4 and 3. Greater than or equal to. So we are actually including the 5, so we include our starting point. And I want x to be greater than 5. I want everything larger than 5. Now remember we talked about with our or statements that it has to work in one or the other. It does not have to work in both. It could, but it doesn't have to. So if I look at all these numbers, -2 is less than 0, so it works in one. Doesn't work in this one, but that's okay because it's an or statement. 7 is greater than or equal to 5. It works in this one. 7 is not less than 0, but that's okay because this is an or statement. It only has to work in one or the other. Now let's look at, say, 2 or 3 here, because neither one of those are graphed. Is 2 less than 0? No. Is 2 greater than 5? No. So neither one of these are graphed or shaded, and neither one of them work, 2 or 3, or any of the other numbers here that are not graphed here. So I'm not going to shade these. And with or statements, we just take both of the graphs, each of the graphs, and we put them on the same number line. So again, I've got a 0 as my starting point for this graph, and I have a 5 for my starting point for that graph. Now be careful because up here when I did that, I shaded everything inside because I wanted and. This one is or. I just basically copy this graph here and copy this graph here. So I have a closed dot on my 5, and I want everything greater than 5, which is in this direction. You could add more numbers to your number line, is fine. My starting point is 0. I'm not including 0 though, so that's going to be an open dot, and I want everything less than 0. And there's your solution. This is your graph for your compound inequality joined by the word or. Alright, so let's take what we've done here with the and the or statements and copy down problem 1, and you're going to do the same thing. I need you to write the inequalities and then make sure you graph your solutions. Okay? Now whether or not you set up the two individual graphs and then put them together, that's completely up to you. That's your process. However, for some people it does prevent them from making mistakes, so be very careful. But copy these down, spend a couple of minutes solving these two problems. Alright, let's look at more compound inequalities here. Let's look at actually solving them. So we're going to solve this one involving and. Alright, so let's look at this. Now, one thing that should stick out in your mind is this does not look like anything you've ever seen. I've got two inequality symbols in the same problem. What is going on? Well, this is kind of like what you just did, except this is before you get the answers. This is what the inequality could look like before you get the compound inequality joined together. Okay? So this is, you could break this apart and make this two separate inequalities and solve it, or you can in fact solve this inequality all together, which makes it a little bit quicker, and it's pretty simple. Okay? So first I just kind of want to ask you a question. If none of this was here, if this just said -3 less than or equal to m minus 4, this would be a one-step inequality. Hopefully you would tell me, oh, that's easy, just add 4 to both sides. Well, that's exactly what you're going to do, because if you look at the inside of this inequality, if I want that m by itself, I've got to get rid of the minus 4. The only difference is I've got two sides. So if I'm going to add 4 here in the middle in order to get the m by itself, add 4 in the middle to get the m by itself, I have to add 4 over here, and I have to add 4 over here. Just think about doing two inequalities all at once. This is with the word and. It's written all together because you can write and statements together. So what I do to the middle of my and statement, I have to do to either side. So what is -3 plus 4? That's 1. Less than or equal to, -4 plus 4 is 0, so I have my m, that's nice. Less than, -1 plus 4 is 3. So there's your answer. Those are your solutions. We're talking about all the numbers. One has to be less than or equal to that number, and that number has to be less than 3. So basically we're talking about all the numbers between 1 and 3, including 1 because of the equal sign there. We're not including the 3. So when we want to graph these, we can make this very easy on ourselves. We use the graph in problem 1 to write our inequality together. But in this one we can actually use our inequality to make our graph. So our two starting points are our end points here, I guess. This would be 1. This would be 3. And let's think about what this would look like. I'm going to cover this up. 1 has to be less than or equal to m, or read it backwards, m has to be bigger than 1, or m has to be equal to 1. m is greater than or equal to 1. So that would mean that I can use 1. That will work. So I'm going to put a closed dot on that point. But if I want m to be larger than that, I would run in this direction, all these points, and go on and on and on forever. Alright, but I got an end point. In this one, I want m less than 3, right here. I want it less than 3. Well, I'm not including the 3 because there's not an equal to there, so I know I have to start there, but I can't include it. And I want m to be smaller than that, so I'm going to run in this direction. But I have an endpoint. So I can't go past the 1 and I can't go past the 3. I want everything between the 1 and 3. Something like 2. It's easy to think of. 2 works. 1 is less than 2 and 1 is greater than, or 1 is less than 2 and 2 is less than 3. That works. But there's your answer. This is your inequality and this is your graph. So fairly simple with the and statement. So what I want you to do is take that and solve this one for y. Now this does have 2 steps in it, so be very careful, but just whatever you do to the middle, make sure you do to each side of your inequality symbols, because you have basically 3 parts here now. Solve it and graph your solutions. Alright, now that's dealing with the and statement. So let's look at questions. We're going to write some compound inequalities and we're going to solve them. Okay, now this is actually a compound inequality that might come in handy for some of you all if you're trying to figure out what your grade's going to be in any of your classes. This one, let's just read through it and let's pick out all the important information. To earn a B in your algebra course, you want a B, you must achieve an unrounded, okay, so we're not talking about decimals and stuff here, unrounded test score between 84 and 86. All right, so I'm going to highlight that. I know I want it between 84 and 86. And what does inclusive mean? Inclusive. Including. That means that not only do I want something between 84 and 86, like 85, but I could also include 84 and 86. I would be okay with an 84 and 86. So inclusive means you include the 2 endpoints. Okay? Now, you scored an 86, an 85, and an 80 on the first 3 tests of the grading period. Not bad. You scored an 86, an 85, and an 80 on the first 3 tests. So pretty good. What possible scores can you earn on the 4th and final test to earn a B in the course? So what possible scores can you earn? What possible scores can you earn on the 4th one? Okay, so I'll highlight that too, on the 4th one. That means you're only taking 4 tests. You've taken 3 of them already, so you've only got 1 more. All right, so let's think about, first of all, what is it asking me for? And it's asking me for the possible scores I can earn on the 4th test. So I'm going to let X represent, always define your variable. X represents the score on the 4th test. That way I know what my answer represents when I get to the end of my problem. X is going to be the score on the 4th test. Now, you all know how to find averages. If I wanted you to find the average of these 3, you would add them together, divide by 3. Pretty simple finding average. But the problem is, we got to find the average of 4 tests. At the end of your course, you're taking 4 tests, so you've taken a total of 4. So if I want to find the average, I've got to add all 4 tests, because that includes the one you don't know, and divide by 4. That's how you find average. So let's set that up. I'm going to find the average of my test score. So the first test plus the second test plus my 3rd test plus my 4th test, which is X, because I don't know it. And when I add all those up to find the average, I would divide by 4. Now, that takes care of the X is what we have here in orange to figure out what we're trying to find. What I have here in pink, that's the 3 test scores. So let's go back to what I have in yellow. I want this to be between, when I find whatever this answer is, I want it to be between 84 and 86. So the lowest score that I will accept is an 84, and the highest score that I will accept is an 86. So those are our endpoints for this problem. 84 is the lowest I'll accept, and 86 is the highest. Now it does say inclusive. So let's think about this. This average, whatever this is, once I solve this for X, my X, once I add all these together and divide by 4, this average here cannot be more than 86. Okay, it's got to be between 84 and 86. So I can't make this more than 86. Now, inclusive means it can be equal to 86, but since it can't be more than 86, it's going to be less than or equal to 86. So let's think about our 84. what we get here, I don't want this to be less than 84. If it's less than 84, we're talking about 83, 82, 81, and I might not get a B in this algebra course. So what I have here has to be bigger than 84, which means my 84 has to be less than whatever I get in the middle, but it is inclusive, so it can also be equal to. So that's your inequality. That's how you set it up based on what we have highlighted there, based on this problem. So now all we have to do is we just need to solve for x. We've got to solve this so that we can figure out what do you need to make on that fourth test in order to get a B in your algebra course. So let's do some simplifying. I'm going to leave this 84 here, less than or equal to, let's add all this stuff on the top that we can, like terms. 86 plus 85 plus 80, those are all like terms. So if I add those, I get 251 plus x divided by 4 less than or equal to 86. Alright, now we've got to solve this for x. Now this is an inequality, a multi-step inequality we haven't actually discussed yet, but if you're analyzing these and determining what's the last thing I did, because that tells you what's the first thing you're going to do, read this. 251 plus x, so the first thing we did to x was add 251, then divided by 4. 251 plus x divided by 4. Dividing by 4 is the last thing I did, so that's what I've got to undo first. Well, what is the inverse of dividing by 4? Well, the inverse of dividing by 4 is multiplying by 4. So I'm going to squeeze a little 4 in there. I'm going to multiply by 4. But if I multiply the middle by 4, that means I've got to multiply the left by 4, and I've got to multiply the right by 4. I've got to keep everything balanced. So what I do to the middle, I have to do to each side. So 84 times 4 is 336 less than or equal to, now since division and multiplication here are inverses, that's how I'm able to eliminate those. I get 1. So I'm left with my 251 plus x less than or equal to, and now I need to multiply 86 times 4, and that gives me 344. And notice that this number is still bigger than this number. Okay, we're still keeping everything balanced. Alright, so 251 plus x. I have a positive 251 in the middle with my x, so the inverse would be to subtract 251. So if I subtract 251 from the middle, I have to subtract 251 from either side. Alright, so what is 336 minus 251? Well, that's an 85. Less than or equal to, now this is our 0, that's why we do the inverse, so I'm left with that positive x there in the middle. Less than or equal to 344 minus 251 is a 93. Alright, but we need to analyze. What does this mean? I have an 85 now, I have a 93. What does this tell us? Okay, so what this tells us is that your score, write it out as a sentence, your score on the fourth test must be cover up the your turn question here. We'll get to that in just a minute. Your score on the fourth test must be between 85 and 93 inclusive. Remember, inclusive means you can make the 85 or you can make the 83, and that's okay. And there's your answer. This is what your inequality is telling you. Now think about this logically. You score an 85, what do you think your score is going to be in class? Probably an 84. Okay, unless something else is going on in there. And if you score a 93, what's your average going to be? It's going to be on the higher end. So this just tells you you have some options in there of what you've got a little leeway between 85 and a 93, so a pretty good leeway there in order to get somewhere between an 84 and an 86 inclusive for your test. Now you're going to need this information here. You need to think about this information for this your turn question because we're going to change it up a little bit. Suppose these are the 3 test scores you have, and we want to know, is it still possible to earn a B? Okay, now 100 is maximum grade. We don't have bonus points where we have over 100 test scores. But make sure that you show your work on how to solve this and then explain your answer. What does it tell you? Are you still able to get a B in this class if these are your 3 test scores? Okay, so do that your turn problem there, writing and solving compound inequality. All right, now let's look at solving inequality, compound inequalities involving OR. All right, OR statements are can be a little bit easier because OR statements cannot be written together, so we don't have to worry about going that extra step and trying to combine these. They have to be left as 2 separate inequalities. Now, one problem I do have with some students on OR statements is that they get so used to the AND statements where they do whatever they do over here, they have to do over here, and so they start trying to subtract 2 from everything. Okay, these are 2 separate inequalities. So what I suggest doing, especially if you're afraid you're going to do that, is write them further apart. Give yourself some space, or just write the first one, and let's just take care of that one, and then we'll take care of the other one. Whatever is going to help you. Well, this is a 2-step inequality. 3 times t plus 2. Plus 2 is the last thing I did there, so first thing I undo, so I'm going to subtract 2 from either side, both sides. I'm left with a positive 3t, because 2 minus 2 gives me 0, less than negative 7, negative 2. I'm down 7, I'm going down 2 more, so I'm down 9. Notice my inequality symbol did not change with subtraction. Now the inverse of multiplying by 3 is going to be dividing by 3. 3 divided by 3 gives me 1, so I'm left with 1t, less than negative 9 divided by 3 is negative 3. Now even though I'm dividing into a negative number, I did not divide by a negative number. These are both positive, so my inequality symbol did not change. So there's t less than negative 3. That represents that inequality. All right, so let's take care of this inequality over here. Negative 4t plus 5 less than 1. All right, well, the last thing we did was add 5, so that's the first thing we undo. So subtract 5. Negative 4t is what we're left with there because 5 minus 5 gives us 0. Less than, be careful, 1 minus 5. We're at 1 and we go down 5, so we're at negative 4. The inverse of multiplying by negative 4 would be to divide by negative 4. Make sure you keep everything nice and organized and lined up, and this will keep you from making mistakes. If I divide both sides by negative 4, negative divided by negative gives me a positive. 4 divided by 4 is 1, so that positive 1t. But you should be on high alert here because this is negative and this is negative. I have divided both sides by negative, which means this inequality symbol has to flip. All right, and a negative divided by negative is a positive, and 4 divided by 4 is 1. So here are my 2 solutions. T less than negative 3, t greater than 1. So I'm going to rewrite these just a little bit closer together. And these are combined by the word OR. T is less than negative 1 or t is greater than 1. That is, or those are my solutions. Now you could think of some numbers that are less than negative 3, and you could think of some numbers that are greater than 1. Remember, it only has to work in at least one of these. It doesn't have to work in both when you're dealing with OR statements. All right, so now we need to graph this. And you can set this up just about the same way you did your AND statement. I can draw my number line, and put in my two endpoints, my two starting points. I have -3 and I have 1, making sure that you have your number line set up correctly. Please don't interchange those. That happens sometimes. Make sure your number line's correct. Let's look at this. T less than -3. Well, I'm not including the -3 because there's not an equal sign there. So I have to start here, but I can't include it. And before I draw anything, I want to think less than -3. Less than. That wouldn't be towards the 1 because 1's not less than -3. So that would have to be in this direction. Alright, but let's see what this one is. Let's see if there's anything special I have to do here before I move on. T greater than 1. Alright, well I'm still not including this endpoint, so that's going to be an open dot. And I want everything larger than 1, which is not going to go in this direction because -3 is not larger than 1, so it's going to go in this direction. So basically what's happening here is these are my endpoints and they are going out. So -3, T less than -3 would be in this direction. T greater than 1 in this direction. There's your inequalities, and here's your graph. And you can pick numbers and plug them in to double check your answers. Alright, so take that OR example and apply that to your problem, your turn problem 4. Again, you have an OR statement. Solve each one of those for y, being very careful with your rules of solving inequalities, and make sure you graph your solutions. Alright, something that we need to talk about. I told you earlier in the video that we would talk about something called interval notation. Interval notation includes the use of 3 special symbols, and that's what I've got broken down here. These are the symbols we're going to use. The first one, parentheses. Now, OR is not in parentheses. These are just, obviously you know what parentheses are, but use parentheses when you're talking about less than or greater than. So this is important. You're going to talk about less than, or if you're going to talk about greater than, you're going to use parentheses, okay, because you're not including the numbers that you have listed there, okay? Then the next set you will see are brackets, okay? Brackets, these are your brackets here. You're going to use brackets whenever you're talking about less than or equal to or greater than or equal to, because you are including the numbers. So parentheses indicate you're not including, brackets mean you are including the numbers. And then the third type of symbols that you're going to use are the infinity symbols, which you've seen before. But just to refresh you, this symbol will be used if you're talking about continuing forever in the positive infinity direction. Okay, so that means if you're going everywhere, all the way to the right, to positive infinity. And then this symbol you're going to use if you're going to talk about going forever in the negative direction, so negative infinity. Now think about this. Can we include infinity? Would we use a bracket or would we use parentheses when we're talking about infinity? Is there a stopping point? And there isn't. Infinity goes on forever. So you can't use a bracket because there's no such thing as including infinity. We use a parenthesis because that is going to go on and on forever. So let's actually look at how we're going to intertwine all of these different symbols here into a problem. So question 5 here. What is the graph of this interval notation, and how do you write that interval notation as an inequality? Alright, so let's look at how we're going to set this up. Okay, first of all, we have a bracket, okay, which means we include -4. Because remember, we talked about brackets mean we include. Right here we have a parenthesis, which means we do not include 6. Now, interval notation is going to be used whenever we're describing intervals on a number line. When we're talking about and statements, we can use interval notation, or if we're talking about one specific inequality and we're going on forever. Now, in positive or negative infinity, which would be your OR statements, because you notice on your OR statements we would have an endpoint going to negative infinity and an endpoint going to positive infinity. So if you're going to use interval notation for those, you will actually have 2 sets of interval notation for your ORs. If you only have one such as this one, especially since we are starting and stopping, we have definite endpoints, then we're talking about an and statement here. All right, so let's set up what our graph would look like. We just recognize that we are including -4, but we're not including 6. So let's just set these up on our number line. -4 and 6, and you can write any numbers you would like on the inside of that. I'm going to put 0 in there just so that we know we're talking about all these numbers between -4 and 6. But you can add other numbers if you'd like, before and after. We're including 4, or -4, excuse me. So if you're including, remember that is a closed dot, but we are not including the 6. So that would indicate open dot. So including -4, not including 6, but we want everything between -4 and 6. So again, this represents an and statement between -4 and 6. And now we've already written and statements as inequalities from the graph. Okay, so let's do that. -4 is our lowest point, 6 is our highest point, and we need something to represent everything in here. So make it a variable. Let's switch it up a little bit. I'm going to make it a y. All right, we are including -4, but notice all of these numbers here are bigger than -4. So we are including -4 with our equal sign, part of our equal sign, but y, everything in here, has to be greater than -4. So that means the large end of our inequality symbol has to be facing the y. So -4 again is our smallest point, so it's going to be less than y. And then 6 is not being included, so I can't put a little equal sign here because we're not including 6, but everything here that we have shaded is less than 6. So y is going to be less than 6. So here is the graph of this interval notation and the inequality of that notation, which we did from the graph, but you could also set up this inequality from your interval notation. All right, so I want you to take that and do your turn problem 5. Graph this interval notation and write it as an inequality. Be very careful how you set that up. Okay, so let's sum this up here. You've got 2 summary questions. First one, I want you to solve this compound inequality, making sure you graph your solutions. So you need to determine, is this an and statement or an or statement, and what rules should I follow? And then question number 2, you do have a number line here, and I know it is a little bit harder to identify. This is your starting point, and the line is shaded in this direction. Now this is a little bit more challenging than the 2 interval notation problems you just had. So this one, if you need to go to your book and look up an example of this one, make sure you do that. But write this graph in interval notation and as an inequality.